So you've definitely heard of things like ChatGPT, you've seen all that incredible AI art, but what is the actual tech that's making it all happen? Well, today we are going beyond the buzzwords. We're going to pull back the curtain and really understand the revolutionary architecture that changed everything, the transformer.
And it really all boils down to this one fundamental question. You see, for years, this was the biggest roadblock for artificial intelligence. How in the world do you get a machine to grasp the full context of what you're saying, and not just, process a string of separate words?
To really get why the transformer was such a massive deal, we got to take a quick step back and look at how things used to work. Before transformers, the main technology out there was something called a recurrent neural network, or RNN, and it had a very, very specific way of reading, one word at a time.
Now, the big problem with these older models was that they processed language sequentially. They'd read one word, then the next, then the next. And not only was this super slow, but the real killer was that the model would often forget what it read at the start of a sentence by the time it got to the end. The context would literally just disappear.
Now, researchers knew this was a huge issue, and they came up with some pretty clever fixes. The most famous one was called long short-term memory, or LSTM. Think of it like a system of little digital gates that would try to let important information through to be remembered for longer. But at the end of the day, it was really just a band-aid on a system that was fundamentally flawed.
And here's the perfect example of where it all fell apart. Look at this sentence. The animal didn't cross the road because it was tired. For older models, figuring out what it refers to was a massive challenge. Was it the animal? The road? Because they just couldn't hold on to the full context, this simple little pronoun was a total mystery. And this is the exact problem that had to be solved.
And then, everything changed. The transformer wasn't just a small improvement, it was a completely different way of thinking. It introduced an entirely new way for machines to read and, more importantly, to understand language. And here is the secret sauce. Instead of reading word by word, the transformer reads the entire sentence in one shot. It processes all of the information in parallel. This is the secret to its incredible power, and it's the key that unlocked the AI revolution we're all living through right now.
So let's break this down. How does this actually work? I mean, how can a machine read an entire sentence all at once and still make any sense of it?
Okay, here's a high-level map of how a sentence travels through this thing. First, it goes in as an input. Then it gets some special info about word order. After that comes the real magic, the self-attention part. Then it gets processed by what we'll call a brain. And boom, we get our output. We're going to walk through the most important steps right now.
First up is something called positional encoding. I mean, think about it. If you read everything at once, how would you know the difference between the cat chased the dog and the dog chased the cat? Well, this is the solution. It's a really clever mathematical trick that basically stamps each word with a serial number or an address, giving the model that absolutely crucial understanding of grammar and sequence.
And now we get to it, the true heart of the Transformers innovation, the component that completely blew everything else out of the water. This is the self-attention mechanism. What self-attention does is pretty mind-blowing. For every single word it's looking at, it allows the model to simultaneously look at all the other words in the sentence and calculate how relevant they are to each other. This is exactly how it solves our "it was tired" problem. It mathematically links the word "it" directly back to animal, no matter how far apart they are in the sentence. It's genius.
And the practical benefits here are just huge. It connects pronouns to nouns, it understands how words that are far apart relate to each other, and crucially, it identifies the key concepts. So in a sentence about the capital of France, it immediately knows that Paris, capital, and France are the words that need the most attention in relation to one another.
And the system actually gets even more sophisticated than that. It uses something called multi-head attention. The easiest way to think about this is like reading the sentence multiple times all at once. Each head or each pass focuses on something different. One might focus on grammar, another on the subject-verb relationship, and all of that together lets it grasp these incredibly complex sentence structures.
Okay, so the attention mechanism has figured out which words are related and how important they are. But where does the actual thinking happen? Well, that brings us to the final major piece of the puzzle.
This is the final step in the process. Now, its technical name is a feed-forward neural network, but you can just think of it as the brain. It takes all that rich, contextual information from the attention layer and starts to really process it, to reason about it, and to turn all those connections into deeper meaning.
Right, this is where it all comes together. The attention layer says, hey, Paris, capital, and France are linked.
Then the brain looks at those links and, based on everything it's been trained on, it understands, this is a capital and state relationship. Paris is the capital of France. This is the step that enables the complex reasoning that we see in today's AI.
So let's just boil it all down to the key takeaway. Before transformers, we had models that could just process words. After transformers, we have models that can comprehend relationships. We went from a slow, context-deaf, one-word-at-a-time process to this powerful, parallel system that understands how ideas connect across an entire text. It was a massive leap.
And that huge jump from just words to actual relationships is what underpins almost all of the modern AI we use every day. Which leaves us with a really fascinating question to think about, right? If teaching machines to understand context was the first giant leap, what's going to be the next one?